Tuition Mobile, quality e-learning experience on the go.
Hello and welcome back to the class. We'll be talking about graphical methods to quadratic inequalities. Graphical methods to quadratic inequalities. Okay, we'll be considering quadratic inequalities. We've done for linear inequalities, and this time around we'll be talking about quadratic inequalities. And like we did before, we'll be illustrating with examples. We're using examples. Alright, suppose we are given the following inequality: x greater than 4 minus x. Okay, I think by now every one of us must have known how to resolve this. All you have to do is to add x to both sides, and so this gives you greater than 4 minus x plus x. Okay, and then this gives you 2x. Okay, why this gives you 4? Because the 2x will take care of both, and then negative, positive, they will eliminate. Then we have that 2x is equal to 4, and the next thing we have to do is to divide both sides by 2. Okay, dividing both sides by 2, and then we'll have that x is greater than 2. Okay, and so x comes out here and is greater than 2. Remember why the sign didn't change is because we earlier said that when a positive sign divides both positive signs divides, the signs remain the same, the signs remain constant, they don't change. Alright, for quadratic inequalities involving expressions, for inequalities involving quadratic expressions, okay, for instance, we have for quadratic inequalities, inequalities or expressions of inequalities involving quadratic equations. Expressions of inequalities, okay, involving quadratic equations. Okay, all right, we'll have, for example, x squared minus 2x minus 3 is greater than 0. All right, what we have to do first is to factorize. Step 1, we'll factorize the expression. We have to factorize the expression. Okay, and then I believe we must have done factorization of quadratic equations. For this purpose, you may like to refer back to your quadratic equations method of quadratic equations by factorization. And if we carry out that, you find out that when we factorize, we have x plus 1 and x minus 3 greater than 0. How do they come about this? Suppose our quadratic equation is x squared minus 2x minus 3, okay, equal to 0, but it's not equal to 0. But because we want to factorize, okay, trying to solve through method of factorization by quadratic, and so we can express it as this. And what we discussed in class 6, that we multiply both the first and the last term, and then we'll have minus 3x squared. We find two terms that can replace the middle term, okay, but when they are summed together they give the middle term, okay, and when they multiply together they give the product we have here. Alright, so the two terms that comes to my mind is minus 3 times 1 minus 3x times 1x, okay, which gives minus 3x squared, and then when we add minus 3x plus 1x, it gives minus 2x. Alright, so we can replace minus 2x here as minus 3x and plus x minus 3, bring down 3 equal to 0, and then we try to factorize both of these and the both of these. While trying to factorize this, x can come outside the bracket, and then we'll have x minus 3 left here. And for this bracket, positive can come outside the bracket, and then 1 also, because 1 times inside the bracket gives the same thing, and so we'll have x minus 3 outside the bracket, both equal to 0. And so we can pick the factors as x plus 1 and then x minus 3, and so therefore the factors in that quadratic expression are x plus 1 and then x minus 3. Alright, and so we go ahead to plot them on a quadratic graph. And then how do we plot them on a quadratic graph? And we have to represent back in inequality form, and then we say this is equal to 0, and this simply implies that x plus 1 is greater than 0, or x minus 3 is also greater than 0. Alright, so how we resolve this by solving them is you can say x plus 1 greater than 0, and then or x minus 3 greater than 0. Remember that when you subtract numbers, the sign changes, but when you add numbers, the signs do not change. So when we want to make x stand alone here, we subtract the numbers, okay, greater than minus 1, okay, and so we are adding 1 to both, so we are subtracting 1 from both sides, okay, and for this, we want to remove 3, we'll be adding numbers to both sides, and this virtually do not change the equation. Alright, and so when we add this, we have that x will be less than minus 1. Alright, is that right? Or x will be greater than we'll add 3 to this side, x will be greater than 3. Okay, so remember that what we said, that x less than 1 and then x will be greater than 3. So this does not logically hold for these two expressions, and so we have to represent them using the number line so that we find out what the actual root of the equations will look like. Okay, let's try using the number line to find the expression. The next step is to determine if it's a negative curve or it's a positive curve. So how do we determine whether it's a negative curve when we want to plot them? Because already we have these values as the outcome of the curve. We have x to be minus 1 and then x to be equal to 3. Okay, then the next thing we have to do is to determine whether the sign changes to greater than, less than, using our curve. Alright, so like I said, we have to determine whether the curve is negative or positive, and how we determine that is by checking on the a of the quadratic equation. If remember we said under quadratic equation, the topic, we said that if a is greater than 0, then the curve of the quadratic is curve shaped. The curve of quadratic is curve shaped. Okay. Meanwhile, if a is less than 0, the curve of the quadratic expression, okay, the curve of the quadratic is cup shaped. Okay, and then what we mean by cup shaped is this. It takes the following shape of a curve, and then this is what we mean by cup shaped. And then when we say it's cup shaped, we have a quadratic equation, and then we have it coming downwards. This is cup shaped. Okay, so this is cup shaped, and the other one is cup shaped. You see, it's fixing downwards, while this one fixes upward. Alright, and so how do we find out whether it's cup shaped or cup shaped? And we said that this happens, cup shape happens if a is greater than 0, and then this happens when x less than 0. Alright, let's look at our quadratic equation. Our quadratic expression is x squared minus 2x minus 3. Quadratic expression x squared minus 2x, and the minus 0 plus 3. Alright, minus 3. Okay, minus 3 is greater than 0. Alright, so I remember ax plus bx plus c. Okay, and so from this expression we see that a is equal to 1 and it's positive, so the curve will be cup shaped. Fine. So we try to plot the curve on the next page. Okay, assuming that's our graph, and then this is the y, this is the x-axis. Although these things do not really look necessary. Negative x, and then here denotes negative y, and then here is our origin, and then we take values 1, 2, and 3, and then from this point we take values -1, -2, and -3. Okay, all right. We try to fit for the x-axis for this curve that we have x plus 1, and then x minus 3 is greater than 0, and from which we have that x is less than x is equal to -1 from this point, and then from this point x will be equal to 3. Okay, all right. So for 3, this is x is equal to 3, and then for -1, this is x equal to -1. Okay, so we can fix the curve. It doesn't need any form of accuracy. Alright, this is a curve we're talking about. Fine. Alright, this is a curve we intend to fit, and then for the x6. Now, after fitting the curve, we have to take cognizance of what happens under the curve. Okay, to solve this quadratic equation, to note what happens, we pay particular attention to the inequality less than. Okay, we pay particular quantity. So hence, it will be only for the shaded parts. All right, only for the shaded parts, the inequality says less than, and so since it's less than, it will be outside the curve. Okay, this will be the shaded part for less than x less than -1. That's so. Sorry, x greater than x greater than 3, and then x less than -1. Fine. All right, x greater than 3, and then x less than -1. I think that's what we had here. Wow, right. So for x less than -1, you have outside equality, and then for greater than 3, you have curves at this point. Alright, the curve will be greater than 0 only for the two parts, and we do not want the curve to become negative, but we want the curve to become positive. So that's why the x value should be x less than -1 or x is equal to 3. Alright. So why do change of sign occurs in inequality? Change of sign in inequality. Change of inequality sign. Let's find out what happens when signs change in inequality. Alright. This can occur under some conditions. We've studied these conditions before, but let me just remind you that this can occur under the condition number 1, that when we multiply or when we divide throughout, or multiply or divide throughout by a negative number. By a negative number, the sign changes. When we multiply out or divide by a negative number, the sign changes. For instance, you have 3 is greater than 1, and then we multiply by a negative number. This becomes -3 greater than -1, and this is false. So once it changes to -3, it becomes less than -1. And then number 2, we have that the sign changes when we take reciprocals. When we take reciprocals, okay, of both sides. Reciprocals of both sides are taken. Alright, so assuming we have 3 is greater than 1, and then we take reciprocals, 1/3 is greater than 1/1. This cannot hold. So for this to hold, the sign changes to 1/3, becoming less than 1. Because 1/1 is equal to 1. Alright, so we take another example to represent our quadratic graph. Example 2. Example 2, if -2x squared plus 3 is greater than, sorry, minus 2x squared minus 2x squared minus x plus 3 minus 2x squared plus x plus 3 rather is greater than or equal to 0. Okay, so how do we solve this? First of all we need to do is to multiply all sides by a negative side. Multiply all sides by a negative sign. Okay, and so this becomes minus into minus 2x squared plus x plus 3, okay, greater than or equal to 0. So negative into this gives negative, negative, positive x, 2x squared, then negative times positive, negative x, and then negative times positive, negative 3, greater than or equal to 0. Negative times 0 is 0. And so we go into factorization again, and then we're trying to factorize, just like we said, multiply the two terms, we have 6x squared. Okay, and so the factors that multiply together to give 6x squared are 2 times 3, and then 2 minus 3, I mean 2x times 3x, or you can say 3x times 2x. Okay, so that under the multiplication we can say that 3 right, so we have minus 6x rather. Okay, so that we can say minus, and then minus 3x plus 2x will give minus 1x, which is equal to minus x. Alright, so we can replace as 2x squared minus 3x plus 2x minus 3 greater than or equal to 0, and then we bracket these two. Alright, the factor can come out of this, and then the factor here is x, and then you have 2x minus 3, and then some other factor can come out of this bracket, that's just 1. Then you have 2x minus 3 remains positive, greater than or equal to 0. Okay, we have that x minus 1, x plus 1 rather, as the two factors, and the 2x minus 3 as the other factor, both being greater than or equal to 0. Okay, so having gone to this point, we have factorized. We are only saying that x plus 1 is greater than or equal to 0, or that's and x 2x minus 3 is greater than or equal to 0. So how do we get along with this? Alright, this makes us to subtract equality signs from both sides. So this gives x is less than or equal to minus 1. Okay, and then alright, when we add values, when we subtract values in the equality signs, and then for this part we have to subtract add 3 to both sides. 2x minus 3 is greater than or equal to 0. We have 2x is greater than or equal to 3, so that x itself will be less than, x will be less than or equal to 3 over 2. Okay, dividing both sides by positive, and then this side we have x is less than or equal to 1. Alright, does it really change? X is less than or equal to 1? No. Alright, this means that x, let's take this from 1 minus 1 gives that x is greater than or equal to 0. Sorry, minus 1. Okay, x is greater than or equal to minus 1. Alright. And so at this point we try to locate points under the graph, and then we'll have to plot. Ordinarily what the equation says that minus 1 is less than or equal to x, and then x is less than or equal to 3 over 2. Okay, so x is the point between is a point between -1 and 3/2. So we try to plot x. Try to plot x. Alright, and so we have a schedule of the curve we want to plot, and just like this is my y-axis, negative y is my x-axis, and my negative x. Okay, and so at the origin there I have 0. Alright, and then my points here 1, and then points 2 and 3. I have -1, -2, and the -3. So how do I plot this curve? I have that x. I have that x is less than 3/2, and then that x is less than or equal to 1. Okay, so we'll find out what happens here. Example 2, we have to simplify the inequality. Example 2, we have to simplify the following inequality. So we have the example 2 as -2x² plus 3 greater than or equal to 0. Okay, there is an omission. -2x² plus x. Alright, so when you have inequalities like this, you multiply both sides. By negative. Okay, when you multiply both sides by negative, we have negative 2x² plus x plus 3 greater than or equal to 0, and so you have -2a² minus x. Okay, negative times negative gives you +2x² minus x. Negative times positive gives -3, and then this changes the sign to less than or equal to 0. Okay, and so from this point we solve the quadratic method. We multiply these two terms and the last term to obtain 6 minus 6 x². So the two numbers I can add and subtract to get the middle number are -3x plus 2x. Okay, to give -1x. Okay, so we replace that as the middle number, -3x plus 2x minus 3 less than or equal to 0, and so we factorize the two terms here. So factorizing them, you have x out this bracket and 2x minus 3 remaining, and then you have +1 2x minus 3, okay, less than or equal to 0, and so we have that x plus 1 is less than or equal to 0, or 2x minus 3 is less than or equal to 0. Okay, further solving demands that we add -1 to both sides of the equation here. Here I have x plus 1 minus 1 less than or equal to 0 minus 1. Okay, so this becomes x is less than or equal to -1. Alright, so from x is less than or equal to -1, and from the other side of the equation we have 2x minus 3. 2x minus 3 is less than or equal to 0, and so from this side we add 3 to both sides, and then we'll have 2x is less than or equal to 3, and then we have that x itself is less than or equal to 3/2. Okay, x itself is less than or equal to 3/2, so we have x is less than or equal to 1, and then x is less than or equal to 3/2, as 2 points. All right. Okay. So we have to plot this on the inequality graph. We have to plot this on the inequality graph. Okay, so x is less than or equal to 3/2, or x is less than or equal to 1. Okay, so we can, since we carried a division on this part, and then another part we had x is less than or equal to -1, not just 1. Okay, I think that's where the confusion is coming from. X than or equal to -1, so x cannot be less than or equal to -1, and as well be less than or equal to 3/2. So it's either x is less than or equal to -1, and then sorry, x is greater than, because the sign changes, equal to -1, or x, and x is less than or equal to 3/2. So we can write the inequality as -1 is less than or equal to x, and x is less than or equal to 3/2. So the side we would like to plot is the side, the points under x. And so we draw our inequality, we fix our inequality quickly. Ask sticks. Okay, and then this is our y, this is our -y, this is our x, and then this is our -x, and then we'll have 0, of 1, we have 2, we have 3. Then at this point we have -1, -2, and then -3, and then x equal to -1 is at this point, and x equal to 3/2, which is 1 whole number 1/2 is 1.5, is at this point. Okay, so we can fit our curve for this point, okay, good. And the area we are interested in is looking at the sign. The areas are the area under the curve. Okay, so these are the areas under the curve, because x is less than or equal to 3/2, okay, and x is -1 is less than or equal to x. So this is our area of consideration. Alright, keep practicing exercises like this, and then take good note of the signs, okay, the inequality signs. Now you know the conditions that change them. Okay, why this one virtually changed? Okay, you could have two good reasons why the signs changed at that point. The first reason is that there is negative subtraction. Okay, subtraction on both sides changes sign. So it was at this point we could have changed it, but we aren't solving using the other method. So we had to wait when we got to trying to see it logically from the logical point of view. Good day.